Hi, everyone. Thank you for sticking around. It's the last presentation. Pierre will go first.
Wow, thank you for the introduction, Henry. Yeah, so we're going to talk about program changes to the way we run labs and assess labs in the School of Chemistry. Sorry, camera. Okay, in the School of Chemistry, and this slide basically highlights where we were. So this IR spectra should not look like what it looks like. This doesn't tell you anything. There's no usable information on that spectra. They've basically forgotten to put the sample into the machine, but they haven't noticed. They haven't noticed for 24 hours until they've sat in front of an academic, spending a lot of time analysing the signal in this spectra, of which there is none. So nothing meaningful can be made from this data, yet they've built a whole poster assessment on it, and that's like 6 weeks into the lab. So when we're using those larger summative assessments that come after they've been in the lab and after they've produced all of their written artifacts, we run into this kind of problem, and also the AI issues that we've talked about a lot today. So we're going to talk about how we redesigned the assessment in labs, bringing a lot of it into the classroom so that we pick this up early, and simply by being at labs, students are learning and being assessed at the same time. So Henry will talk about Chem 1 and probably take up most of the time, so you might not hear from me again.
All right. So just to be clear, this is the title, but we're not against lab reports per se. But we're talking about a structure where the lab report is scaffolded in a way that promotes learning. So we're going to talk about what we've done at several stages of our lab program so students can actually learn from this process. So we're talking about growth. We're not talking about assessments per se, but it's the learning process behind that. So for Chem 1A, this is, we have about, I think there are 3 units, up to 3,000 students per year. Last semester, we had about 2,200 students. So for this one, lots of interesting stuff. People have been talking about interactive oral assessments. Exciting, fun, but with a scale of over 2,000 students, it's a bit hard. So what we decided to do was, so for one of the assessments, which is the capstone assessment for the labs, they chose one communication mode. It can be a technical report, it can be an infographic, it can be a video, or we ask them to write a letter to the APA to communicate their lab findings. So this is, we are trying to teach them how to communicate their scientific understanding. So for this one, we built cognitive agents with the hope that students could get personalized guidance on their drafts as they worked through these assignments. They could improve, so they had unlimited chances to improve their work before submitting. And most importantly, for me, it was to reduce my administrative load because during the time of the assessments, a discussion goes nuts. Like you have 200 questions and you have to answer each one of them. What does this point in the rubric mean? What do I have to do? Like, how do I get started? So all these things. So this is the structure, classic cognitive interface. So we fed the agent, the marking rubrics and the assignment structures, what we expected, and some of the administrative stuff. We asked students to input their drafts, so they would come up with the first draft and then feed it to the chatbot and ask questions in terms of matching against the rubric or just getting general feedback. It was optional. We found that 67% of the students out of the 2,000 students used the chatbots, about 2,500 conversations. And we were actually happy that it wasn't a matter of how do I get, like, what, give me the structure, give me what to do. It's like students really engaged. On average, each conversation was about 15 turns. So they would go back and forth with a cognitive agent. And they were using it to get feedback on their drafts, which is what we anticipated. They were asking for alignment with the criteria, asking the chatbot about how well they were doing against what we had published. And sometimes it was about getting started. I don't know actually how to start this report. How do I get started? Which was really nice to see. So at this stage in Chem 1, Chem 1A is very diverse, so we're just getting these students excited about chemistry. That is why we choose this mode of assessment. Now, Chem 1B, this is after students have done the first semester of chemistry. We now move into the lab. So lab competency for us means much more than just the submitted assessment. It is the technical competence. Can you actually perform the techniques? Can you actually make decisions in the lab? Can you operate safely in a lab? So all these things that we cannot see from the lab report. So this is another checkpoint. Now, moving from the communication, now going into can they demonstrate their competency in the lab? So we designed a station-based lab test. So students come in and rotate through a series of stations. Each station is testing a specific skill. So station 1 could be on dilution. How do you have this concentration? Can you prepare this much of this concentration? They can do filtrations. They can do chromatographic techniques. They can do all sorts of stuff. So they the way we ran it is we had 15 students at a time per lab space. We have multiple lab spaces. So 15 students, someone can start with skill number 2 and then go to 3 and then go to 1 and then they get out. So it was feasible. At each of the stations, we are looking at competency, we are looking at accuracy and precision, we are looking at the reasoning behind what they do, behind the procedures, and we are looking at how are they actually operating in the lab? Are they professional? Are they acting safely? We asked students about what they thought about this kind of assessment. Now we are talking about technical competency and the reasoning. They liked it. They thought it was clear. They thought it was fair. They thought it was really aligned with the learning outcomes for the lab. So that was nice to hear. Importantly, they said it actually encouraged them to engage in the labs because they knew there was a test at the end. They were forced to learn the skills. They were forced to start thinking about what it meant, what the data meant. We also looked at, with all these dimensions that we are looking at, we looked at the students' scores. We found that generally students could actually complete the steps. We have lab manuals, they've done this many times, so they can actually maybe carry out a titration, they can carry out a dilution. They could be precise, which is a good thing. But sometimes when it came to the reasoning, that was hard. When you start questioning, why did you choose this kind of glassware and not this kind of glassware? That is when you start saying what is lacking or what the students cannot do well. So at this stage, we start saying, we start digging deep into what students actually know. Of course, we had an exit survey. They were telling us the lab steps are easy, but when it comes to reasoning, it is actually a bit hard. So this is another checkpoint from one communication mode, which was the written report, to now the in-lab lab competency. That was a different checkpoint. Pierre is going to talk about third years. We're going to skip second year for now, not because we are not doing anything about it. We are doing some stuff there, but we don't have enough time to go into the details. Third year.
All right, so third year, we just had to make them talk. Students would do their best to avoid talking to demonstrators. So they're basically the tutors in the room. They circulate the lab, helping students as needed, but there's no formal, normally there's no formal part in that program where students actually have to talk to demos. And that's why you saw that kind of thing in the first slide happen. Students were dodging those conversations. So most of the changes in assessment was to try and get feedback to our students and try and formalize those interactions that students had with their demonstrators, because it is only through those conversations that you can ensure they're achieving the learning outcomes that we are trying to achieve. Did this in a four-stage model, if you want to call it that, where we're grabbing students at important times in their learning in the lab. So this starts when they're physically doing a particular step, asking them why they are doing it. So that first step, understanding the why. If you normally go and ask students why they're doing something, they'll tell you because you told me so, right? They'll say, it's written down, that's why I'm doing it. So here we embed within our program, hey, at this point, someone's going to ask you why you're doing that. So you better understand what you're doing and why. The next step is interpreting their results. So that spectra we showed right at the start, what are you seeing? So if they talk to a demo, the demo would have said, you probably want to run that again because it's not really telling you anything. The third step is that more formal scientific communication. There are reports, our posters, so they still exist, but they come after students have shown us that they understand the underlying data and how to interpret that. So go to AI, I don't care, but you verbally need to explain that to me as well in the lab. And the final step is design your own experiment and defend that experimental design and the interpretations that you are making. So step 4 was our, I guess you call it a capstone. It was our Viva, where they make their own experiments. So if you're a scientist, this is, I guess, the fun bit and also the hard bit to implement in a teaching laboratory. Safety is an issue. If you get students trying to design something, they're going to want to use things that aren't safe because they don't know better. So you need to put guardrails in all sorts of places for them to make their own assessment and the experiment, I should say, and then run that in the lab. We then assess that through a Viva. So that was the one in-person point of contact between our academic and the students. And this replaces a summative lab report that they used to do and was marked by an academic. Okay, so lots of places for feedback in this lab, and that's what the redesign tried to do. So for the first time since 2021 in the USS for all our senior chem units, there wasn't a single comment saying we want more feedback in labs. Instead, they're saying we get assessed too much, basically. So a fine line to thread. But I also asked them in an in-lab survey, look, what did you think of the feedback? Is it timely? Is it useful? Generally positive perceptions, telling us nice things, that it's doing what we're trying to make it do for our students. What didn't they like? A lot of it is formative. So little assessments and lots of touch points. They told me it's not really worth their time. So you're saying, I need to do all this work for 1%? No thanks. They're not convinced that doing a verbal conversation in class and then repeating that same kind of substance in a formal report is useful. They don't appreciate that, even though we're trying to get them to learn different skills. One is to check you understand what you're doing. The next is to turn it into a formal scientific document. They're very different things. So we need to be clear on why we're having them assessed on the same thing multiple times. And for all the in-lab stuff, they like to get all those conversations done in one lab right at the end. So in week 12, they'd email me and say, can I get my week 2 conversation signed off today, please? And that's not the purpose of those assessments, right? They should be going through the program, and as they come to that step in the lab, have that assessment done on the spot. We are done.
Yeah.
Questions?
Okay, thank you. Do we have questions? Oh, there is a question somewhere. Oh, I'm going to go all the way over.
So this is going to be kind of broad, but you've got enough of it for me to ask you this question. Because you've got sort of a Cogniti thing going, and you've worked with ed discussion, and you've worked with trying to get demonstrators to talk to students, I'm always worried that Cogniti is making people more scared to ask what they perceive as a stupid question. And I'm wondering if you can see a difference in the number of people asking in-person questions or ed discussion questions or Cogniti questions, depending on before or after Cogniti was introduced. I know this isn't that relevant to this, but it seems like a good person to ask.
I still got a decent chunk of questions on ed discussion after introducing Cogniti. So I don't really think Cogniti discouraged them from asking questions. What I know is it actually encouraged them, because in ed discussion or on ed discussion, we don't have space for them to upload their drafts. So the engagement is like, oh, I don't know how to do this. Can you clarify what this criteria means? And then you answer. So it's more of question and answer rather than them deeply engaging with, the chatbot, with the agent who is providing the feedback. So it's Cogniti is just another opportunity for them to engage deeply with feedback rather than being discouraged from asking from other sources.
Yeah, no, that seems good to know. I just wasn't really sure.
Yeah, thank you.
All right. Okay, well, thank you, Henry and Pierre. Again, thank you again. Okay, that gets us to the end of our program.